Hello everybody. Today I will show you how to define a Zener diode model in SPICE and how to use it in a simple circuit. First of all, we build our circuit as we have done for the junction diode with a voltage source, a voltage source, a resistor, and a generic Zener diode we can find with components and then looking for Zener. We place the component on the schematics and we wire the mesh. We add the ground, and we put some values for our components. 0 volt DC, 1 kilo for the resistor, and now we define our model for the diode here. So first of all, we change the name of the component by pressing the control button and at the same time right-clicking on the diode. So right here, for example, a specific name like my Zener diode, and then we define a SPICE directive with this button .op. We define a dot model with the name my Zener diode of our component. The type of the component is the diode, so we say D. And then in between parentheses, we define the parameters of our diode. In some parts, they will be the same of the junction diode that you've seen in the previous tutorial. So for example, R on equal 0, R off equal 1 mega ohm, V forward equal 0.7 volt, and now we add another parameter which defines our Zener diode behavior. That's it. That is the reverse voltage or the breakdown voltage, which name of the parameter is Vrev equal to, means that the reverse voltage will be equal to minus 2 volt in this component. We close the parentheses, push OK, we place the directive here, and then we define a simulation for checking if our diode is working properly. So we go to Simulate button, edit simulation command, and we want to sweep source P1 with a linear sweep between, let's say minus 5 volt and plus 5 volt with an increment of 0.1 volt. Okay, we place here our simulation, we run it, and now we plot the current flowing through our diode. And we actually have what we expect, what we wanted to, in the sense that here we have zero current between minus 2 and plus 0.7 volt, minus 2 and plus 0.7 volt, and then we have direct bias flowing, current flowing, and reverse bias current flowing.